In this video, I'll introduce you to Container Map, the main dashboard for WhaTap Kubernetes, and a key feature of observability. At the top of the blocks in the container map, you'll see the container and key resource quantities. At the bottom of the blocks in the container map, you'll see metrics related to CPU, memory, and application transactions. Container maps provide information about the current state, as well as the state of the past. Use the time selector in the upper right corner to see which information was monitored at a specific point in time in the past. Let's go back in time. You can see that the container status for the same time frame a day ago is being printed out. At the top left of the screen, you have the option to set the container map to container view and pod view. In Kubernetes, containers are deployed in pods, so it's important to look at them with a pod view as well as a container view. When you switch from container view to pod view, the blocks representing individual monitored objects change their appearance. Let's go back to the container view to explain. By default, the container map displays blocks all expanded, but you can also group them in any combination. Let's select namespace as the first level of grouping and node as the second level of grouping. First, you'll notice that the containers in your project are separated into cards by namespace, which is a first-level grouping setting. The containers inside each namespace card are then grouped back into nodes. To the right of the grouping options, there is a list of criteria states for displaying the container map. This option allows you to set which criteria each block should be displayed by. So let's change the baseline state value from the default value of constate to event constate. You can then see that the warning and critical containers are identified, unlike the previous container state. When you hover over a container in the critical state, it shows that one application-related event has occurred. This means that the container state itself is fine, but an event has occurred in the application running inside the container. This time, let's select the mem-by-limit metric. The mem-by-limit metric for a container is a metric that shows the actual memory usage as a percentage of the memory limit value assigned to the container. To the right of the list of baseline state values, there are settings options represented by cog icons. This option allows you to set how the information in the container map is displayed. For example, you can store and manage the name, application type, and display status of each block, including the currently selected baseline state value for each user's browser. To view blocks based on their current utilization against the CPU limit assigned to the container, you can set the baseline state value as CPU by limit, label it as selected metric, and have each block display the real-time value of CPU by limit. The color of each block in the container map is affected by the thresholds corresponding to warning and critical at the top. Now let's change it to warning 70 and critical 80. Each block will then have a blue color if the metric value is 70 or less, an orange color if it's between 70 and 80, and a red color if it's above 80. To the right of the warning and critical thresholds, you'll find the filter settings which allow you to specify monitoring criteria. You can choose to display or exclude only the blocks that meet your conditions based on keywords. So let's filter to show only namespaces with a specific name. And the rightmost reset button will reset all user settings. Now let's look at the ability to monitor in more detail. It's not hard if you want to see the status of a particular block in detail. Just click on it. The top of the summary screen provides information about the block. If the block is a container, you'll see the container the pod it contains, the replica set and deployment running that pod, and the namespace of the pod, and the node it's running on. At the bottom of the block information, you'll find the image information for that container. If the container has a WhaTap application agent installed, it will also show the agent name for that application. At the bottom you will find the observability tabs traces, metrics, logs, and events. The Traces tab contains a summary of the applications running in the selected block. This tab is only visible if you have installed the WhaTap application agent. The Metrics tab displays CPU, memory, and network resource metric values for the selected block. The Logs tab provides information about the contents of container logs and application logs generated within the selected block. The Events tab provides Kubernetes cluster event information for the selected block, as well as event history information set for each WhaTap user. You can see summarized information for the entire group, not just a single block. After grouping into namespaces, let's look at a summary of all the blocks inside a namespace. When you view a group of observations rather than a single block, the block information at the top of the right-hand side, summary, is not displayed, and the observability tab appears immediately. You can also view traces, metrics, logs, and events in groups. On the other hand, if you want to narrow down a specific monitoring target and get more detailed information, click the Go to Detail button on the right side of the summary. The Detail view of a container map provides more detailed information about the target selected in the summary view. And of course, the overall organization of the traces, metrics, logs, and events tabs are similar to the summary screen we saw earlier. In the bottom left corner, you'll see a list of the blocks available in the Detail view. You can expand each block to see basic configuration information. Click the link button on the right side of the pod information to display the Master Meta Information menu. Click Master Meta Info to display the meta information for that pod stored in the Kubernetes control plane. In addition to monitoring performance information, you can also view meta information about a specific resource from within WhaTap. This time, let's click on the Container Info link to the right of the Container Info. You can see basic configuration information about the container, including limit request quotas for CPU memory resources. You can also get an at-a-glance view of the nodes those containers are running on. On the right side of the Detail view, you'll see a larger, more detailed view of the traces, metrics, logs, and events you saw in the summary view. Trace is only displayed if the WhaTap application agent is installed on that block or a group of blocks. The main information is active transaction, hit map, TPS, concurrent user, HTTP SQL count, etc. You can also check heap usage and GC trend depending on the type of application. Hitmap provides information about the distribution of requests and response times of transactions over time. Drag the desired point in time and response time to display a list of transactions that meet the criteria. You can view detailed trace information for each transaction by clicking the individual URLs in the transaction list. Click Active Stack on the top to filter and view only the transactions that contain active stack information. The active stack refers to the information stored by ongoing transactions, which is automatically dumped periodically. Normally, you wouldn't be able to create a dump after an issue has passed, but WhaTap periodically creates active stack dumps, so you can analyze when issues have occurred in the past. By clicking on Multi-Transaction, you can selectively view transactions that are running in relation to other agents and projects. Especially in microservices environments, multi-transaction analysis is critical. A metrics provides real-time information about the current resource usage and trends used by the monitored object. You'll see metrics from different perspectives for CPU, memory, I/O, network, and more, which are the most common observations in Kubernetes and container operations. Logs provides the log contents generated by the monitored target. Containers have a shorter lifecycle than virtual machines, and typically all data inside the container is lost at the end of execution. In addition, Kubernetes often creates and kills pods on its own due to features like auto-scaling and auto-healing. This makes it difficult to view or manage logs in Kubernetes in traditional ways. WhaTap Kubernetes centrally stores logs generated by each container and the applications running on them. This ensures that no logs are lost upon container termination and enables you to search through logs under different conditions. The logs in the log list starting with app, such as app log, correspond to applications running on top of the container. Among that list, Container Scout holds the logs generated at the container level. Kubernetes events, which are directly provided by each Kubernetes cluster, encompass information about changes and errors occurring within the Kubernetes environment. Like container logs, this Kubernetes event information is short-lived in Kubernetes, but WhaTap allows for some degree of long-term archiving, searching, and analysis. WhaTap events refer to information about events that occur when a specific situation arises, or when a set threshold is exceeded, which you define. That's it for the basic use of the WhaTap container map.